friends, in this new video we see how to apply the Euler's method to solve the first order differential equation. In the previous video we have seen what is the Euler's method. Now I have written one problem. Dy by dx equal to y minus x divided by y plus x, where y equal to 1 at x equal to 0. This solution for x equal to 0.1, and we have to deduce this up to 5 step. Now here what is our h? Delta x is our h, and delta x is equal to final value xn minus x0, so 0.1 minus x0 is 0, and up to 5 step, so this will be divided by 5 and we get 0.02. Now friend, dy by dx, delta x equal to dy by dx, delta y equal to dy by dx into delta x equal to dy by dx is here y0 minus x0 divided by y0 plus x0 into delta x. So first here x0 equal to 0. Now we have to find up to 5 step. So x1 equal to 0.02, x2 equal to 0.04, x3 equal to 0.06, x4 equal to 0.08, and x5 equal to 0.1. This is the value required to initiate the solution. Now first for the first step we need the delta y. Delta y equal to y0. What is our y0? At x0, at the initial value, we consider this x0 equal to this value as x0, and at this x0 this value of y is 1, so we consider it as a 1. So this is the value of x0 and y0, and to initiate the Euler's method we need these initial values. So we call this as an initial value, and we find the 5 steps. So that means up to the point x is equal to x5, and that will be 0.1. So y0 equal to 1, x0 equal to, so we get this delta y equal to 1 minus 0 divided by 1 plus 0 into 0.02. So this will be, this is 0.02. Now first step. So what is our Euler's equation for first step? y1 equal to y0 plus delta y equal to, what is our y0? y0 is 1 and delta y is 0.02. So we get 0.02. Now for the second step, second step, this is at, this value is at, we have considered x1 at 0.02. Second step at x2 equal to 0.04. Now we need once again delta y. Delta y equal to y1 minus x1 divided by y1 plus x1. y1 is 1.02, x1 is 0.02 divided by 1.02 plus 0.02 into delta x is here. Delta x means 0.02 equal to, I have already calculated this value for you. Now the value of this is equal to 0. We get this value is 1 divided by 1.04 into 0.02, and then we get 0.0192. Now y2 equal to y1 plus this delta y. y1 equal to 1.02 plus delta y is 0.0192 equal to, and this y2 will be 1.0392. This is our second step. Now third step, and it is at x2 equal to 0.06. Now again we need delta y. So delta y equal to here y2 minus x2 divided by y2 plus x2 into delta x equal to y2 we have calculated 1.0392, x2 is minus 0.04 divided by 1.0392 plus 0.04 into 0.02, and this value is now 0.0185. From this y3 equal to y2 plus delta y. What is our y2? y2 is 1.0392 plus 0.0185, and we get this value as 1.0577, and it is at the point x equal to 0.06. So fourth step is for x, this is x2, this is x3, okay, and fourth step is x at x4, and it is at 0.08. So delta y in this case is y3 minus x3 divided by y3 plus x3 into delta x. y3 is 1.0577 minus 0.06 divided by 1.0577 plus 0.06 into delta x. Delta x is 0.02, and it is 0.0179. So y4 equal to y3 plus delta y. y3 is 1.0577 plus 0.0179, and it will be estimated as 1.0756. And our last step of this problem is y5. y5 is at the point x5 and x5. So fifth step 5, it is at x5 equal to 0.1. Again we need delta y. The dy by dx is at the point y4 minus x4 divided by y4 plus x4 into delta x. y4, our y4 is 1.0756 minus 0.08 divided by 1.0756 plus 0.08 into 0.02, and it will be 0.072. So y5 equal to y4 plus delta y equal to y4 is 1.0756 plus 0.0172 here, 172, and it will be 1.0928. We have likewise we can apply the Euler's method to solve the first order differential equations.